everybody. In this video, we're going to talk about properties of parallelograms. Now, there are a lot, so stick with me here. The first one we're going to talk about is basically the definition of a parallelogram. Both pairs of opposite sides are parallel, right? So that's what we see with these markings right here. Some arrows, those are saying both sides are parallel. That's just the definition of a parallelogram. The second one, opposite sides are congruent. So if we do have a parallelogram, then its opposite sides are going to be congruent. That's what those tick marks mean. Similar to that, opposite angles are going to be congruent. Okay, so we see our opposite angles there are congruent. Number 4 says consecutive angles are supplementary. So if we see consecutive angles would be like angle A and angle B right there. That would be one example, or we could even do those two angles right there. Because basically we have our parallel lines cut by a transversal relationship going on there. And so that's where those supplementary angles come from. Number 5 talks about the diagonals. The diagonals bisect each other. So keyword there, bisect. That means that the two diagonals where they intersect, basically they intersect at the midpoint of each of the diagonals. And that separates the diagonal into two congruent segments. Okay, so that's what we see here. And the last one pair of opposite sides are congruent and parallel. So if we're trying to prove that a quadrilateral is a parallelogram, and we can prove that one of the sides or pairs of sides is parallel and congruent, then it is a parallelogram. Okay, so let's look at some examples. Example number 1 just says find the values of x and y. So we know that the diagram or that the shape is a parallelogram because they've given us that both sides, opposite sides are parallel. So now we can think about some of those properties that we just looked at. So we know that opposite sides are congruent. So that means we could say 3x minus 1 is equal to 20, so that we could solve for x. So we get 3x equals 21, and we get x equals 7, okay? Now we can also use the fact that opposite angles are congruent, and we can say 2y equals 54, and we can divide by 54, and we get y equals 27, okay? So we've solved for those. Example number 2 says ABCD is a parallelogram. Find the measure of angle A. So now notice what type of angles we have here. We have consecutive interior angles. So we know these two angles are going to be supplementary, which means when we add them together, they equal 180 degrees. So 4x and x would be 5x. And now we can divide both sides by 5. And we get x equals 36. But now be careful, we don't want 36. We want 36 times 4 because we're trying to find the measure of angle A. So 36 times 4 would give us 144 degrees, okay? All right, so let's talk about some parallelograms in the coordinate plane. We'll look at 2 examples here. The first one here, example 3, tells us to do 2 things. Find the missing vertex of parallelogram ABCD, then find the coordinates of the intersection of its diagonals. So if it's parallelogram ABCD, we have A, B, and D. So we know that vertex C must be somewhere over here. Okay, so now how can we figure this out? Well, we know that the opposite sides need to be parallel. Well, parallel means they have the same slope. So if I can find the slope of line segment AD, I can apply that to line segment BC, and I can locate point C. So if I start at point A, I'm going up 1, 2, 3, 4, 5, 6. But once again, make note of your increments. Each line here is actually half. So really we're going up 1, 2, 3, and we're going left 1, all right? So 1, 2, 3, and left 1, and my line appears there, okay? So that's where our vertice C is going to be. So let's take that away, and now we can connect to form our parallelogram, okay? So the missing vertex, vertice C, that's gonna be at 5, 3, okay? So now they want us to find the coordinates of the intersection of the diagonals. Now remember, the diagonals bisect each other, which means when we draw the diagonals in here, they are going to bisect, or they're going to intersect each other at the midpoint, okay? So we can use the graph, we can look at it, it looks like, okay, it looks pretty good, like 3, 1.5. All right, but we can use the midpoint formula to be a little bit more exact. So let's use vertice D and B. So D would be 0, 3, and B would be 6, 0. So remember, for the midpoint, we're gonna say x1 plus x2 divided by 2, and y1 plus y2 divided by 2, okay? So basically add the x coordinates, divide by 2, add the y coordinates, divide by 2. So for DB, we're going to say 6 plus 0, so 6 over 2, comma, and then 3 plus 0, so 3 over 2. So we get 3, comma, 1/2, 1 and 1/2, excuse me, okay? And which is what we thought there, right? 3 and 1 and 1/2, and that would be the coordinate of the intersection of the diagonals. All right, and the last one says, show that the quadrilateral is a parallelogram. So there are a lot of ways to do this. We could do what we just did, and we can find the midpoint of each of the diagonals. And if it's the same, that means it's a parallelogram because the two diagonals bisect each other, or they intersect at the midpoint. We could find the distance of all four sides, and we know that the opposite sides should be congruent. We can't really do anything with its angles here on the coordinate plane. Another thing we could do is find that if one pair of sides are opposite, or one pair of opposite sides are parallel and congruent, then it's a parallelogram. So let's do that one, okay? So let's use let's do AC and BD, okay? So let's find the distance from A to C. We're gonna use our distance formula here. And I'm gonna say 4 minus 0 squared plus -2 minus 0 squared. And that's gonna give us 4 minus 0 would be 4 squared. -2 minus 0 would be -2 squared. And we get the square root of 16 plus 4, which is the square root of 20, which would be square root of 4 times the square root of 5. So 2√5 would be my distance there. So now let's find the distance of BD. And let's do -2 minus 2 squared plus -2 minus -4. So -2 plus 4. And -2 minus 2 would be -4 squared plus -2 plus 4 would be 2. And we get 16 plus 4, which is the square root of 20, which also is 2√5. Okay, so now we know that these two sides are congruent. Now if we can prove that they're parallel, then we can prove that this is a parallelogram. So all we gotta do is find the slope. So let's just do rise over run. So slope of AC, let's start with C and go up 1, 2. So that's 2 over, and then left 1, 2, 3, 4, so -4. So this reduces to a slope of -1/2. And now let's find the slope of BD. Up 1, 2, so 2, and then left 1, 2, 3, 4, 2 over -4, which also reduces to 1/2. So now we know that these two lines are parallel, okay? So they're parallel and they're congruent, and so now we can say, yes, this is a parallelogram, okay? So there's a bunch of properties of parallelograms.